Hey class. Okay, so we are going to take just a few minutes to take a look at these example problems for drawing voltage drop diagrams and trying to figure out like which bulb is the brightest bulb in a circuit. Um, and as we go through this, I guess first I want to make sure that everybody has at least given these a try, right? At least go through, give these a try, see what you can do on your own before watching the solution, okay? Um, but anyways, so the first thing we want to do is we want to go through and color the circuit. So I like to start over here and say, okay, I'm going to color this red, right? And you can't change color in a wire, so all that wire there is red. And then I start on the other side and I do the blue. So this is going to be blue and it's going to come up here and all that's going to be blue, okay? And then I've got one other wire that I can color here, so that's going to make this all yellow. All right, now I need to sit here and think about, okay, how is this going to play out? So in the voltage drop diagram, you have the top voltage here, and you have the bottom voltage down there. And right here, this is always 0 volts, right? Where we start up here at whatever the voltage of the battery is, some number, and that voltage is going to drop as the different elements of the circuit consume the power from the battery, right? So now let's look at the light bulbs that we have. Okay, everything's colored. Check this out. I've got light bulb A right here. And notice that it hooks directly between the red and the blue. So I can come here and I can just immediately put, look, there's light bulb A. It connects directly from red to blue. So it's seeing the full drop of the whole voltage. And by the way, that's going to let us know that automatically that A has to be the brightest bulb in the whole thing, right? It sees the full drop from red to blue. Then let's look at the other one. So if I'm following this path, right, the current splits right here, and some of it goes this way, and some of it goes this way. But if you look right, so you have this path that branches out, and it splits again. So I'm going to have a branching path to B, and then I've got B. It splits again, and that's connected to C and D. And some of the things that we want to kind of ask ourselves as we're looking at this is how are these things connected to each other? I mean, I can look and I can say, hey, when I'm looking at C and D, I notice that they both have blue on one side and they both have yellow on one side. So that automatically tells me that there's a parallel relationship between the light bulb C and D. They're connected in parallel, okay? And if you remember the tricks and kind of the things that we talked about from the other day, is that when light bulbs are connected in parallel, that makes for less resistance, right? It equates to a smaller voltage drop, right? Because there's less resistance. And we kind of mentioned how, I mean, you can almost think of this as like, so right here before the split, it's like the pipe is this big, but then after the split, now there's a lot more pipe for the current to flow through, so that resistance is less. And whenever the resistance is less, it makes for dimmer bulbs. Okay, so because I know that this C and D combination has a lower resistance, that's going to put this yellow line further down here. And I don't know exactly where it needs to go. If we were doing the math behind all of this, we could calculate it. I just know that since B is all by itself right here, it's going to have a big drop. And C and D, this combination, is a smaller drop because they're connected in parallel, okay? So if I was writing this out, I would say, okay, A has to be the brightest, right? It gets the full drop. B is the next one that has the biggest drop, so then B, and then the last one would be C and D have the same drop, okay? So A is the brightest, then B, and then C and D would both be pretty dim in this circuit, okay? And I'm just looking at this and I'm coloring, and I make this decision of where to put this yellow line based on, I look and say, hey, B's all by itself, C and D are in parallel, so they're going to make a smaller resistance, lower drop in voltage for them. All right. So that's what that first one would look like. This next one, let's go through and color it. So I have my red split. I don't change color. I have the blue over here. Blue, blue. Now I'm going to put yellow on this side. So this yellow connects to these, and then there's green in between here. And it does this weird thing where it connects to both of these. All right, so start my voltage drop diagram. And here for this one, again, light bulb A, it connects directly from red to blue. There's A, easy, done. Okay, now if I kind of continue on, then the next thing I run into is B, and I can kind of look across B and say, okay, well, what's on the other side of B? Because I'm going to need a yellow line somewhere, and I'm going to need a green line somewhere, right? And so I need to figure out, okay, where are those lines going to go? And for this, like, this is kind of a tricky combination. I mean, imagine if I pulled this straight. So it's like you have the red wire, and then it connects to B. I'm just going to draw it like that. So here's B. And then you have this yellow wire, and then it splits. And then you have C and D, and then a green wire that is weirdly joint to itself and then connected to, let's see here. This is C and D, and this is E and F. And then finally, E and F are connected to the backside of the battery at blue, right? So I can still see the red to blue, and I know I need to put a couple of lines in here. Okay, now looking at this and applying a rule, so if I look at E and F and C and D, I can see that, hey, look, green, blue, this is a parallel connection. Yellow, green, that's a parallel connection. So, like, one way to think about this is it's as if anytime you make a connection like this, so if I were to draw this in size, like B, let's pretend its resistance is that big. The resistance of light bulb B is that big. So this one, as a unit, it would have a smaller resistance. And this one, as a unit, would have a smaller resistance. But these two resistances are the same. Okay? And the reason why they're both small, but they're the same, and that's because these are all the same light bulbs, right? This is one light bulb. This is another light bulb. Here's this one. Here's, I mean, they're all the same. I have two in parallel. And so that gives me these resistances that are equivalent. But as I drop from red to blue, okay, I have to drop through a big resistance and then two little ones that are the same. And again, if I wanted to, I could calculate these exact values, but I just know that this big R, it's this drop is bigger than the other one. And then I have a yellow level, and then I have a green level, and I tried to split this so that this gap is equal to that gap, right? Because there's the big R, and here's the littler r and the littler r. Like, if you kind of think about what I was trying to show over here. Okay, so this would be B, and this is C and D and E and F. Now, one of the cool things that you can do, and so if I was writing this out right, A would be the brightest, then B, and then you'd have C, D, E, and F, all the same brightness, right? These are all the same because you have two in parallel here. And they're sharing the drop with this big guy. Now you may kind of like think back and say, hey, let's look at C here. What if we compared this C to that C? Right? So it's like, let me erase some of this stuff. It'd be like comparing this bulb to that bulb. Which of those bulbs would be brighter? Um, and the answer to that question is that this one would be brighter, okay? And the reason why is, as I drop from red to blue, and here I drop from red, whoops, that's blue. Here I drop from red to blue way over here. This C has to split the voltage drop between a big resistor and then another small one, whereas this one is only sharing the split with a big one. And so the way that you would partition out the difference between top to bottom, right, it partitions out differently depending on like how many pieces you have to move around. So this C, since it's not sharing as much, would, if I were comparing it to this C over here, this C would be brighter. But that's just kind of like another layer of this, another way to think about these things. Okay, so okay, let's look at the last one. Okay, so I'm gonna do red here, not changing colors. I'm gonna do blue. This blue is gonna come over here, and then I need a color that's in between these two, and I'm just gonna call that yellow. Now, I don't want to use yellow right here because I've got a lot of stuff going on this side, and so I know that this yellow level is not going to be the same place as wherever this other level is. So I'm just going to color this green. Now notice I can't change color in a wire. Okay, so since this is all wire here, all of that is going to be green. Okay. All right, so now let's draw the voltage drop diagram. So I have to drop from red down to blue. Let's look. This first path is the easiest. I have B and A connected in series with yellow right in between, so I'm going to draw a yellow line right here, and B and A are just going to split that evenly. So here's B and here's A. Okay. Now, let's look at light bulb D here just really quickly for a second. Notice if you look at the color difference across D, it's green and green on either side. So what does that tell you about light bulb D? Well, it should tell you that D can't light because there's not a difference, there's not a voltage difference. These light bulbs can only light if there's a difference in voltage across them, and since this is all the same wire, D has been essentially cut out of the circuit. So D is not going to light. D is sad. No lighting for D. All right, but C, E, and F will light. Now, so if you look at this, I've got red to blue drop, and I have something in. All right, so this thing is connected to these two, right? And these two are clearly in parallel because they're green blues. And what does this situation remind you of? Well, it's the exact same scenario that I had over here. Yeah, I stuck D in there, but D won't light. It's doing nothing. So D doesn't affect it at all. But this is the same situation as I had over here, where I had this red to blue, and then a parallel thing in between. Okay, so I know that this is going to be the bigger consumer because the parallel thing is going to be less. So I'm going to put my green line somewhere down here, and so here's C, and then E and F go here, and then D sadly won't light. Okay. So now if I'm listing this, you have A and B have the same brightness, and they're the brightest things. Actually, no. Take a look at this. Which is the brightest bulb in this circuit? C is the biggest drop. Since B and A have to split this evenly and C gets a bigger drop, C is going to be the brightest. Then B and A, then E and F. That's crazy, right? Yeah, so since these have to split this evenly, and C gets a bigger piece of the pie because E and F have their parallel combination makes them a smaller resistance than C, that makes that situation play out like this. Okay, so that's the solution. to all of these things. And I hope you kind of saw as I went through like the different rules that I was applying. Well, as we went through and modified these. Um, so again, looking at this, I've got again, like coloring this is so important, right? Start with the red, then do the blue, then figure out what colors you're going to use in between. And normally, if you have like different branches, unless the branches are identical, you're not going to want to use the same colors to denote those levels, those intermediate levels, okay? But this is the layout and how this works for these three setups. Um, and I'll probably make one more little series so that you can see some of the bulbs from the lab last time. But these are the solutions to these ones. And again, if you have any questions about this stuff, send either Lou or I a message or make a comment. So thank you so much. Bye.